Some important terms in this triangles, in congruency in triangles. Let us know some important terms in this. So median and altitude I'll explain. First, when you see the word median, so median of a triangle corresponding to any side is the line joining the midpoint of that side with the opposite vertex. Let us take the triangle. Now in this triangle, three sides ABC. Median of a triangle, which is line joining the midpoint of that side with the opposite vertex. So from vertex A, if we join the line to the midpoint of opposite side, so BC midpoint, let's take BC midpoint is D. So these two are equal. D is the midpoint of BC from midpoint of one side to the opposite vertex. If you join the line, this is called the median. So now AD is the median in this, right? Again, we can make three medians total. So from vertex A, we have done one, right? Let's take the same triangle. In this first example, AD is the median. Take say ABC. ABC. So total three medians we can make. And from the B to midpoint of opposite side, right? Again from the C, midpoint of opposite side. Here is these two are equal. These two are same. So let's keep some letters name E and F. Let me, this is E and F. So in first diagram, AD is a median opposite to the side BC. Next in this diagram, BE is the median opposite to AC, and in the CF is the median opposite to AB, right? So by taking these three in one diagram, so the triangle has the three medians and all the three medians are always concurrent. That is, they intersect each other at one point only. Let me take three medians to construct in single diagram. So one triangle, instead of taking separately, just in one triangle itself, three medians I'll take. Now ABC, as per the rule, from vertex A you should join the midpoint of opposite side, right? And from the B you should join the midpoint of opposite side. From C, if you join the midpoint of opposite side. So this is D, E and F, right? So these 3 points will join at one point itself. So they'll coincide in only one point. The triangle has three medians, no? And all the three medians are always concurrent. Concurrent means they intersect each other at one point only. So this intersecting point we can call it as a centroid. So we can denote with G. This is a centroid. So point of intersection of the medians is called centroid. Point of intersection of the medians is called centroid. So here is BC is equals to BD is equals to DC, and AE is equals to EC, and AF is equals to this BF, because vertex to midpoint of opposite side is called median, and the point of intersection of the medians is called centroid, that we can denote with G. Here we have the rule AG is to GD. So A to centroid and centroid to the opposite is 2:1 ratio. Same way, vertex to centroid always. Vertex is B. So BG to GE is 2:1 ratio. So if it is two parts, this is one part. Same way, CG is to GF is 2:1 ratio. So vertex to centroid. So centroid of triangle divide each median in the ratio 2:1. So from vertex to centroid and centroid to the midpoint of opposite side, this ratio is 2:1. Right? This is about the median. So joining the vertex to midpoint of opposite side. Next one, we have altitude. So altitude of a triangle corresponding to any side is the length of the perpendicular drawn from opposite vertex to the side. Perpendicular drawn. Let's take first one. This is a triangle ABC. From vertex, perpendicular drawn from the opposite vertex to the side. From vertex A, if you draw exactly perpendicular to this base, BC. perpendicular, it must be 90 degrees. AD. So AD is the altitude now. So altitude of a triangle corresponding to any side is the length of the perpendicular drawn from the vertex, from the opposite vertex to that side. So AD is the altitude. If you join the midpoint, that is median. If you draw perpendicular to the base, that is altitude. Same way we can make three altitudes here. Right? Let me take the diagram. From every vertex, perpendicular drawn we can make. Three triangles. Same, say ABC. A we have drawn perpendicular. Now from the B we can draw exactly perpendicular to this opposite side. Say E. And from C we can draw perpendicular line. CF. So CF is perpendicular to AB and B is perpendicular to AC. AD is perpendicular to BC. That's why AD is the altitude corresponding to the side BC and BE is altitude corresponding to the side AC. CF is altitude corresponding to the side AB. Right. Now these three altitudes also intersect at one point, that is called orthocenter. Let me show you diagram. Let us take in one triangle, draw three altitudes. Say ABC. So as per the rule, from vertex A, we should draw a perpendicular line to the opposite side, 90 degrees. And from C, you can draw a perpendicular line. From B also, you can draw a perpendicular line. So here is point of intersection of altitudes of a triangle is called orthocenter. So you can denote with O. We will denote with capital O. This is orthocenter. The point of intersection of altitudes of a triangle is called orthocenter. Right. So here is perpendicular AD is perpendicular to BC. Same way as B is perpendicular to AC and CF is perpendicular to AB altogether. So that point of intersection of altitudes of a triangle is called orthocenter. So we have the median and altitude. Median intersection point, no, that's a centroid, and altitude intersection point is orthocenter.